Good day, viewers. In this virtual class, here we're going to look at this problem before us, how to find the derivative of inverse trigonometric functions. Here, the first one before us is y is equal to sine inverse of x over a. So here we're looking at how to derive the arc sine of x over a if y is a function of sine inverse of x over a. We're going to use some identity from trigonometry to establish these facts. First, if we look at this question before us, we see that from indices we have a raised to the power minus 1 is equals to 1 over a. So here, that is, this can still be written, y can still be written as x over a all over sine, okay? Then the next step is we will multiply both sides by sine. So here we have a sine times y is equals to x over a divided by sine, so that this will be off, and here will become sine y is equal to x over a. Okay. Here we'll make x. We're going to make use of this. Then from equation 1 there, we multiply both sides by a. Let's multiply both sides by a, so that this become a sine y is equal to x over a times a, so that here this will be off and s will become a sine y. But here what we are looking at, we are trying to find the y dx of this function. We are differentiating y with respect to s. But here, because of the inverse aspect of it, what we do first, we find the x, the y of this. This become a cos y. Okay, we understand the fact that if we are looking for the y ds, we invert this. We take the inverse, divide by 1. So so that our dy dx become 1 over a cos y. Okay, but here we are finding it with respect to x. Okay, so but here we are seeing y here. That means we need to get rid of y. From equation 1, let's go to our trigonometry ratio. From the right angle triangle, this is a, b, and c. From equation 1, sine y, let this angle be angle y. Sine, we know that sine is opposite over, that is SOHCAHTOA. Sine is opposite, from here sine y is opposite over hypotenuse. Opposite is here, opposite of this angle is AB, while the hypotenuse is AC, so which is A. Here, if we are looking for cos y will be adjacent over hypotenuse, and this is the adjacent of this angle. It's missing, so we have to use a Pythagoras theorem to establish the fact. So here, b square, BC square is equals to AC square minus the line AB square. So our BC there, BC is equals to the square root of AC square, which is A square minus S square. Okay, so that is that. So now, so that our cos y the ratio of cos y, which is car, is adjacent over hypotenuse, which is BC, which is a square minus s square, divide a. Okay, that is the value of cos y. Okay, then we put this into this expression, and our ds become 1 all over a times the square root of a square minus s square divided by a. Here, this a will go with this a, and everything eventually become 1 divided the square root of a square minus what? S square. So this is the value of the derivative of sine inverse. Sine inverse of x over a is equal to 1 over a square minus s square. Now, quickly, let's look at the one for if y is equal to cos inverse of x over a. So let's establish these facts. Okay, if you recall what we said here, this expression can also now be written as s is equal to a cos y. From here, no, we started from here, and then x is equal to a sin y. So that means s can also be written as a cos y if we transform this following the same procedure. Okay, from here we say that the x over the y here, if we differentiate cos, is going to give us minus. This is minus a sin y. Okay, but here we are looking at x. We are differentiating with respect to s, not with respect to y. Then let's now come to our right angle triangle. Let's establish the facts for cos y. We know that cos, from here we have a cos y. Cos y will also be x over a. So cos, which is car, is adjacent over hypotenuse. So we are going to establish the fact, because we are saying sine here, and sine is what? Is opposite over hypotenuse. So we will find an expression for it, and that expression will automatically become the square root of a square minus s square. So we have established the fact here that the s over the y is minus a sin y. So if I'm looking for the y, the s, this become the y, the s become minus 1 all over a sin y. What is sine? Sine is opposite over what? Over hypotenuse. So we establish the fact that the y over the s here is equal to minus 1 over, we have a here, and the sine we said is sine y here is root a square minus s square all over a. So we establish the fact here and substitute the ratio of sine y here. This become a square minus s square divided by a. So a will go with a, and then our dy over dx. So dy dx become minus 1 over the square root of a square minus s square. Okay, so we were able to, the essence of this is that we don't want to see y, we want to see x, because we are differentiating with respect to x. So we see that our dy dx for sine inverse of x over a is 1 all over a square minus s square. For that of cos inverse of s over a is minus all over the square root of a square minus s square. So this is how to find the derivative of inverse trigonometry functions. So in our next virtual class, we're going to look at for sec, cosec, and cots as well. Okay, please, all you help me subscribe to my YouTube channel. Also share this information to other social media platforms. Have a nice time. See you in my next virtual class.